We have been listening to a lot of security-oriented things from the morning. With yet another thing, like we have been saying you should do this, do this. This is yet one more thing to think about when we are implementing security in our organizations. We talked about how the supply chain security works. We talked about how we can choose to be safe and hopefully prevent 0 days uh, exploits being happening to us by having a secure supply chain from the start, from the build to having compliances to safely shipping it through CI/CD, signing, and verification. But at the end of it, 0 days are unknowns for us. We don't know what a 0 day is going to be and how it's going to affect us. So when we are at the forefront of a 0 day, like shell shock, log4j, heartbleed, a lot of references from the beginning. What do we do? How exactly do we prepare when an 0 day happens? Do we wait for application upgrades? Do we wait for the patch from maintainers to happen? Or is there something else that we can do? And that sets the pretext for the talk. Just a quick introduction about who are we. We are software engineers at Accuknox. It's a cloud security startup serving entire cloud native application protection platform. We are also maintainers of a CNCF project called KubeArmor, and we are associated with CNCF advocating for security and other things as well. So with that, I'll hand over to Ramakant to talk about in much more deeper about what I set the pretext for.
So let's discuss the agenda of today's discussion. So we will first discuss about vulnerability management, and then we will see what are some challenges that we are facing with the current state of solution, and then we will discuss what we are proposing as a solution. So a lot of good talks we already have, and most of it has been covered by earlier talks. So I will not repeat myself and save some time, and I will just discuss it in brief. So in general, vulnerability management follows these 3 steps: identify, investigate, and prioritize, and then remediate. So it starts with when we are implementing our applications at code layers. So now that we know that use of open source has been rise, and so in the code section, we have our dependency. We check for dependencies, and if there is any third-party dependency that already have vulnerability, so we don't want that to happen. So we have our code scanners placed in CI/CD pipelines. So when we raise PRs, so our code will get scanned. So some static scanning will happen, and we will get to know about those dependencies, and we will try to remove those dependencies early in the life cycle of the development. And same like after this, we build our container images and then scan the base layers and also our custom application layer to detect the vulnerabilities. And the job is not done yet. We want to monitor all our container artifacts continuously, because like we may publish a 0CV image, but any new vulnerability discovered at any time, and now the images that we have in production, they may have those vulnerabilities. So the current state of solution works well for end vulnerabilities. End vulnerabilities are nothing but like for those vulnerabilities have patches available. But what about the 0-day vulnerabilities? There are no known patches. What we can do? So these are some of the examples that you are seeing, and we see the reference of these in today's keynote session. Log4j, Shellshock, Heartbleed, XG Backdoor. These are some popular and some high severity vulnerabilities that impacted the servers and workloads at scale. So let's discuss some of the trends that has been observed by the security researchers in past few years when it comes to zero-day vulnerabilities. So Google has published these reports, and what we can see here is like in the 2021 itself, the number of zero-day exploitation that has been observed are more than all of the vulnerabilities combined to last three previous years, 18, 19, and 20. So what it implies that the attacks of zero-day exploitation has been increased. And next slide, please. So this another observation, and the same Google published this report in 2023. It indicates that average time to exploit has been increased. So from 32 days now in the 2023, it's just reduced to 5 days. So now that zero-day vulnerability attacks are keep on rising, but also the time to exploit those vulnerabilities has been reduced. So these are just to the current state of the solution, and this give us some ideas that there is a need of proactive solutions to handle zero-day vulnerabilities. Let's look at timeline of some of the popular zero-day vulnerabilities. This is the timeline of Log4j. I just want to highlight the time it takes from the vulnerability that has been discovered and the stable patch that has been released. So it took almost 1 month to stable patch to be released. So, and if we just previous slide, please. Previous one. So if we see the timeline events of the timeline, so the patches has been released very frequently, and let's see a solution to handle these vulnerabilities is upgrading the containers to the patched version. So we will be end up publishing our images very frequently. And is it feasible? Like we want to follow all the process of our development lifecycle, coding, publishing, testing, and we don't want to publish anything without testing. So let's look at another zero-day vulnerability, which is shell shock. So it was exist in the earlier, like from the 1.0.3 version of the kernel, but it was discovered in 2014, and it took almost the same time, almost 4 weeks, to have its stable patch released. So yeah, we have this problem, but what is the solution? Should we just wait for patch? Or we want to down our application? So we realize that there is a need for a more proactive approach, which is the virtual patch. I will request Barun that will explain more.
Yep. So 1 month of application downtime, 1 month of waiting for security patches to happen. That's a lot. And I wouldn't want my application to be down for 1 month or leave attackers, especially when we saw that the attack time to exploit has just reduced to 5 days. So 1 month is a lot from that perspective. I cannot wait for 1 month of, like, what do I do? So that's where virtual patch comes into the play. And what virtual patch essentially is that patches are what? You actually upgrade, you apply a patch to your application to fix a vulnerability. Virtual patches, like the vulnerability is still in your system, but you create a safeguard around it so that the vulnerability itself is not exploitable. So couple of example we'll see. We'll take example of shell shock. We'll take example of some other vulnerabilities as well, and how does that work. So just to highlight, once a vulnerability is detected, you wait for dependency patch, upgrade, rebuild, test, release. That's a long life cycle. And how we saw with 0 days, you might have to do it more than 1 time, maybe 3 times, 4 times, because the first patch itself might not fix everything. While a virtual patch would be you just apply a security patch which contains that vulnerability so that the vulnerability itself is not exploitable. So that reduces, like it's just a single command, especially in a declarative infrastructure where we leverage Kubernetes and everything. It's just a YAML file, you apply it and it's ready. Preparing the patch, there's some consideration to take into that, but we'll discuss about that. We have like you have your entire life cycle management. So your application developer knows what is happening. So while all of this is happening, your actual attack is executing at runtime. And that's where you apply these patches. Runtime infrastructure is where you apply the virtual patch to help prevent exploits from happening. So while your application developer is busy creating new app images, that's also important because you don't want to leave your application vulnerable. So while this entire life cycle of things happen, you have runtime policies leveraging tools like KubeArmor, network policy, Falco, and many other tools which can help you prevent this. So let's dive a little deeper about to our demo. So demo, we have, in the interest of time, we have taken screenshots so that we don't actually type in commands and we fast track things. So we'll leverage Trivy. How many of you have heard of Trivy here? That's a lot. So I assume it does not need an introduction. Next is Kyverno. Kyverno, I am assuming a lot of you know, but still a raise of it needs an introduction. So Kyverno is an admission policy admission policy engine. So when you apply your deployment configuration, it works at the admission level, seeing that what is allowed, what is not. A simple example would be you are deploying your container with privileged access, and you have an admission policy. Your operations person has applied a policy saying privileged containers are not allowed. So those kinds of things, it does its best, and we'll talk how we are planning to leverage it. And finally, KubeArmor. Any raise of hands knowing about KubeArmor? Oh, that's a lot. Thank you. I am a maintainer of KubeArmor, so that's good to hear. But in general, KubeArmor is a cloud-native runtime security enforcement system. What it does, we'll see it in action right now. Quickly, what we did was, we have a cluster of vulnerable workloads. We had a lot of vulnerable workloads just deployed for this demo. So we deployed Trivy. It created a list of, it listed these CRDs. So we have Shellshock, Log4j, some other ones, and you can see that there's critical, cluster is actually vulnerable. So these reports, we have these reports available in cluster. So as we talked about, continuously monitoring for vulnerabilities is important. So the operator helps us understand how much of our workloads are vulnerable. And this is where it helps. And we realize that we have shell shock vulnerability applied, and it had the number associated with it. What do? We know that a vulnerability exists, and we need to deal with it. And we realize that the vulnerability is exploitable. So just to show you, the vulnerability was, it was a simple curl access, but I could access the etc password file, which itself is a huge risk. So we are shocked. Shell shock shocked us. How do we deal with it? So what did we do was, we created a Kyverno policy. This admission policy, whenever a vulnerability report is created, what we will do is, we'll scan for a particular CV and we'll apply the patch for it. So what this will do is, any of your infrastructure having this certain vulnerability will apply this patch. The patch is simple here. We are blocking bin bash. It was like, for the interest of not complicating things, we can apply much more complex patches as well. We'll see it one more which would show that. So we block bin bash. In general, the application does not need to execute bash. So this solves that. And so this was the vulnerability, and this was the virtual patch, and it is applied in an automated manner. And we can see that the exploit itself, when you try to act on it, it gives us internal server error. The exploit is not exploitable anymore. Yeah. So on to next is Dirty Pipe. Dirty Pipe was a vulnerability in the kernel. So what we did was, The kernel version was 5.8.63. Sorry for the misplaced box. But once you have this was a vulnerability in the kernel itself. So any pod deployed on this kernel version would be vulnerable. And we can see that it was exploitable. So similarly, what we did was, we applied a Kyverno admission policy saying any pod getting admitted to this kernel version 5.8.10 less than 102 because it only existed between 5.8 to 5.10. So we created a condition when it should happen, and we created a policy saying, in general, the access to HC directory should be denied, but our application should be able to access it. So it's a zero trust policy saying this is a sensitive asset. We say what application can access and what it should not. So it prevents the vulnerability from being exploited. And similarly, we would have, we have permission denied, but our application, in this case, cat, for simplicity, we can still access it. So yeah, we had in log4j example, but we'll skip it in interest of time. Finally, takeaways. So security is a continuous process. You need to keep it. Once you cannot think that I scanned my images at build time, it had 0 vulnerabilities, I can just forget about it. That's not how it works. You can have new vulnerabilities anytime, and you need to be prepared how can you face them. It involves, we propose a solution through virtual patch, but virtual patch implementation itself requires a framework. How do suppose any security person out there helped us create a virtual patch, how do we apply it? So this proposes a framework using operators, Kyverno, and KubeArmor to how to actually quickly deploy virtual patches. So and finally, we as a community need to geese up and honk up patches. So I generated the fly listening to the keynote morning, but essentially we need to work as a community to have these patches available in real time so that when it takes 5 days for attacker to exploit things, if we can, as a community, build up patches quicker than that, that would always be beneficial for us. Thank you. We'll take questions. We'll be around here. I have some speakers as well. If you can come say hi to us. And this is a QR code for KubeArmor. So thank you.